All right, here we are. Let's look at preparing a diluted solution. Now I know that there was this chart, this table 39. I'm not real concerned with that. Instead, I like these better. So here's pretty typical data that we would be given. You have a stock solution of aqueous 2 molar magnesium sulfate. How many milliliters must be diluted with water to prepare 100 milliliters of aqueous 0.4 molar magnesium sulfate? All right, so here's what I got. I know what I want. I want 100 milliliters of a 0.4 molar solution, and I'm going to start with a 2 molar concentrated solution. My stock solution is always the more concentrated version. So I like to use this equation, M1V1 equals M2V2. And I kind of just plug in what I know, and I'll have one missing variable to solve for. M1 is the molarity of the original solution. Well, the original solution was 2 molar. V1 would be the volume of the original, and that's actually what we want to solve for. How many milliliters of that 2 molar solution must be diluted with water? So we're going to leave V1 as our variable. But I know what I want. I want M2, my final molarity. That's 0.4. And I know V2. That's my final volume. 100 milliliters. Well, now again, all I have to do is a little algebra. We'll multiply and simplify the best we can and solve for V1. Now, it is totally okay if you use milliliters with this dilution equation. As long as V1 and V2 are the same unit, it's totally fine to use milliliters. It's just that they have to be the same. When you have the molarity equation, that is always moles per liter. But with this guy, milliliters is just fine. So I might take the 0.4 times 100 and then divide by 2. And then I should isolate V1. Just doing some algebra. And I get 20 milliliters. Oh, well, that wasn't so bad, right? So they did the same kind of calculation, but I just say plug and chug, like plug the numbers in and do the algebra to solve for your missing variable. So if I wanted to make this solution, let's say this is like maybe a graduated cylinder. Let's see if I can get this right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here's how I would make the solution. I would start with 20 milliliters of the original stock solution. I don't know what color it would be. We'll just kind of make it gray. Magnesium sulfate is actually kind of colorless. So maybe this is like 20 milliliters of the original magnesium sulfate. So that's maybe to the 20 milliliter mark. So it's the original 2 molar magnesium sulfate. And then I want the final volume to be 100. So I'll go back in with my water and I would make the rest of this volume water until I hit my final desired volume of 100 milliliters. There it is. So this might end up being 80 milliliters of water. So that 80 plus 20 gives me my final volume of 100. Now, it's not that I measure the 80 milliliters. I would just squirt water in until I hit that final mark for 100 milliliters total volume. This isn't so bad, right? Okay, so let's try one more. Let's see if we got this. Okay, so question 40. How could you prepare 250 milliliters of a 2 molar sodium chloride solution using only a solution of 1 molar sodium chloride? So first, I don't know why this is a lowercase m. I'm going to make them a big M. Molarity should be a capital M. All right, well, let's do the calculation. Let's see what we got. M1V1 equals M2V2. M1 is the initial molarity. I have a 1 molar solution of sodium chloride. But often we solve for V1 and that we just don't know how much to use. Now we could solve for any variable, but if I'm preparing a solution, it's usually that first volume. I know the original solution's concentration, but I don't know how much to use. I know what I want. I want 0.2 molar, and I want 250 milliliters. Okay, so we just simplify and do some algebra. So I'll go 0.2 times 250 divided by 1. Oh, yeah, 50 milliliters. And so what it means is that I would use 50 milliliters of the original 1 molar solution, and then we would add water until 250 milliliters is my final volume. That's how I would prepare the solution. I would put that 50 milliliters in either a volumetric flask or maybe a large graduated cylinder. I would start with my concentrated solution, which in this case is the 1 molar, and then I would just add water until I hit my final desired volume. Now I can estimate that that's going to be approximately 200 milliliters of water, right? So that the water plus the original solution add up to my final desired volume.